Any of you that have gone swimming in a pool know that as you go deeper into the pool, the pressure of the water increases. You can feel it on your ears. You can feel it pressing in. So let's write this down. Pressure increases with increasing depth. And there's a simple relation for this, and that's going to be that pressure is equal to rho g d, where rho is density, g is gravity, acceleration due to gravity, and d is depth. Done, call it good, we're finished. That's the end of the video. Oh, well, I guess we should do a little bit more. So I'd like to point out to you that this term right here looks a lot like the weight. Looks like weight divided by volume, right? And so what we can figure out from this is that, I mean, pressure is force per area, right? And so if I divided both sides by d, I would now have something that looks like pressure over volume, and I would have weight over volume. Or maybe I can multiply both sides by area and would get something that looks like, well, force on this side and then weight over here, right? So if I say area times pressure is equal to mass over volume, which is what the density is, times g times d times area. Well, this term looks a lot like volume. And so this can cancel with that. And when I say this term over here is a times f over a, those two also cancel. So I get mg, right? So that's where this equation comes from. But there's a little bit more to it than that. This comes from another equation called Bernoulli's equation, which I'll introduce to you now, but we're going to have to do a separate video on because it's worth its own video. But all right, let me write here. So Bernoulli, you've probably heard about this guy in chemistry when you did a little bit in Bernoulli's equation then. So Bernoulli has told us that pressure plus the dynamic pressure is this what this term is called, plus the static pressure, as this term is called, is equal to a constant for a given fluid. Now, probably a more useful way of writing this than saying it's equal to constant is actually saying pressure 1 plus, kind of like you did in the ideal gas law in chemistry, P, or like the relations, you would say like P1 V1 over T1 is equal to P2 V2 over T2, right? So let's just write this over here as a comparison. Gas laws. Like P1 V1 over T1 equals P2 V2 over T2. It's the same idea, because the reason we do that is we say this term is equal to a constant. So instead of just saying, hey, it's equal to some number I don't know, it means if I change volume, something else changed to keep that other term constant, right? So if I increase my volume, then maybe my pressure goes down, right? So that means that I can figure out pressure 1, pressure 2, and volume 2 based on that. So the way we'll write this most time is like this, and we'll assume that density is constant. So pressure 2, density 2, And this is now no longer depth. Up here, we had said in this equation that rho is density, g is acceleration due to gravity. Yes, I do. Yeah. And d is depth. In the format we're writing this here, we need this h to be elevation, but everything else is the same. V is velocity, not volume here. H is elevation, and P is pressure. And the last term we need is, I guess let's do rho because we've done everything else. All right. We'll come back to this one in the next video. I don't want to make this get too long, so see you in the next one. Stay safe out there, guys.